Now let's talk about model training and model fit. So in this video, we are going to talk about training of AI model, the different types of training, and then hyperparameter setting. And then we are going to talk about the concepts of overfitting and underfitting, as well as bias and variance. Let's talk about the training of a model. What is meant by training? So the training of a model is like a education phase of the AI, you can say. Okay. You are going to provide your AI model with some data, and it is using that data to learn. Okay. Then later, with whatever learnings it has, it can provide you the uh, answers or even generate new things, right? So first part is it has to learn. Okay. So we have to provide it with data to learn, and that's what is training. Okay. So now we are going to see some of the types of the training. The first one being the supervised learning. Okay. So the supervised learning is train using labeled data. Now, what is labeled data? Labeled data is a data where we are going to provide the label with the data. Like, let's say we are going to create a model which can tell us the animal name. We will provide it with an image and it is going to provide the name of the animal. Okay. So at the time of training, we are going to provide it with images, and each image will be labeled. Like it will tell, we provide it with an image of let's say a lion, and then we label it with the lion word. Okay. So it knows that this data is for lion. Okay. So like that, we provide it with thousands or millions of images, and then it can be and then when we test it with the image, it can easily identify what is it. Okay. So labeled data is an important concept. Okay. Labeled data means you are providing it with the data and the output expected from that data, or what that data is for, what that data means, you are telling it. Okay. Again, another example you can think of is like a fraud detection. Okay. So in cases we let's say we have a user account frauds, okay, like fake user accounts. So let's say we provide it with account details, hundreds of account details, and with each of the account we provide it with like if it is a fraud or not, if it is a fake or not. Okay, that is the label for that one. Okay, so based on the type of training, the label can be different. Sometimes it can be labeling just like it is a fraud or not. Sometimes it is labeling what this object is for, right? So whenever we use this kind of labeled data, we are talking about supervised learning. Now, what the model does in supervised learning is it tries to learn the mathematical function to map your input and output. Okay, when it understands that mathematical function, so the same mathematical function it can use further when you are going to ask it. Okay, so that function it is again going to use and now predict the results for you. Now, some of the applications of supervised learning are like for predictions, forecasting, fraud detection, and classifying objects within the image. Now, let's talk about unsupervised learning. So, here in the image, you can see the first one, you can relate it with a supervised learning. There is a supervisor with you, which is instructing you, which is helping you to learn. And in the unsupervised learning, you are learning on your own. No one is telling you what it is, right? Okay. So unsupervised learning is training on unlabeled data. So you are just being provided with the data. You are not being provided with any labels for that data. Okay. So this unsupervised learning has some specific use cases. Okay, so let's see about that. So what in unsupervised learning, what the model tries to do is it can do things like finding hidden patterns, structures, or relations within the data. Okay, and then the applications you can think of like grouping. So grouping is like you have a lot of images or you have a lot of reviews and you have to group similar reviews together or similar images together, right? Or anomaly detection. So within a group of or a set of images or data, you can find like this one is a different one, right? Because we haven't trained it with what it is, but even then it can find like this is different or these are similar and these are different, right? So these are some of the applications like grouping, anomaly detection, and data compression as well. So data compression is also similar to like the concept of grouping, you can say. It tries to group the similar data together and then since this is like reappearing, so it uses it to compress pattern it tries to find in the data and then uses that to compression, data compression. Okay. Now the next type of training is the reinforced learning. So the reinforced learning is based on the feedbacks and rewards. So how it works is here is your model, and in this case, the model has to perform actions. Okay. So again, this has separate use cases which we will see. So the model has to provide some action, and when it takes that action, so on each of the action, it is going to be provided with a reward. The reward can be either positive or negative or neutral. Okay. Or feedbacks also. Okay. So this is like a trial and error method. Okay. So the model will try the every possible action and then we'll see which one is the best one. Okay. And not just like the single action best. Okay. It's like from the start to end, it is trying to collect the maximum reward. Okay, not just on the whatever current state it is. So it tries to take a next step, and it does not just try to get the reward from there, but from the start to the final state, it will try to collect the maximum reward. Okay, so the applications are like gaming. Gaming is a very major concept where we are going to use this reinforced learning, and then we have like self-driving cars, robotics. Okay. Now there is again these small concepts like semi-supervised learning. Semi-supervised learning is simply first you train it with some labeled data, okay, and then you are going to train it with unlabeled data. Okay, so like a small amount of labeled data you have to provide first, then you are going to provide it with large amount of unlabeled data. And then we have self-supervised learning, which is like you are going to provide the model with unlabeled data only, but the model itself will be labeling that data, pseudo labeling. Okay, as per its understanding, it will create pseudo labels for the data. Okay. Now let's see the steps, the training, the validation, and the test. So training, as we have seen, is the first part where we train the model. Okay. So let's say if we have a data set, okay, a large data set comprising of, let's say, thousands of data. Okay. So out of that, 60 to 80% we are going to use for the training of the model. Okay. So training phase is like reading textbooks. Okay. We are going to provide it with textbooks and the model will learn through it. Okay. Next part is the validation. In the validation, we are going to use the 10 to 20% of the data set which we had. to validate if now the model is able to answer correctly. Okay. The 60 to 80% we already used for training. Okay. In the training, we are going to provide it with data, maybe labeled or unlabeled, and it will train. Okay, at that time we are not going to ask it questions, we are just providing it with data, and it learns at that time. Okay, now once it learns, we are going to validate if it has learned correctly or not. So for that we are again going to use the 10 to 20% of the data, and then we are going to see if it's able to understand or not, if it able to answer or not. Okay, so this is like a practice pitch for your model. Okay, and then if we are not satisfied with the performance of the model, so there are some hyperparameters of model which we can tune. What are these hyperparameters? We are going to discuss in later section, but you can just remember for now that we can tune the hyperparameters to optimize the performance in the validation step. Now the final step is the test stage. The test stage is like the final testing of your model. Your model is now ready. You trained it, you tuned the hyperparameters to get the optimal output for you, and then you are going to test it, okay, in the real world. So this is like your final exam for your model. Okay, so here again we are going to use the last remaining 10 to 20% of that data. Okay, so that's about the training, validation, and test. Now let's talk about hyperparameter. So hyperparameter are basically rules for training your model. Okay. And so whenever we are training a model, there has to be some rules set up on the model so that it the training is best suited. Okay. There is no predefined rule that this hyperparameter should be having this value, right? Based on what type of model you are building, what type of training data you are giving to it, you have to set the hyperparameter. So there can be case like you set up the hyperparameter initially, you train the model, then you validate it, and then you are not happy with the outcome. So you have to adjust the hyperparameter again and do the training again. Okay. So let's see some of the common hyperparameters from the exam perspective. First is the learning rate. Okay. So learning rate is the step size. So how fast your model is going to change its mind during the training. What does it mean is like your model is going through the training data. Okay. And it's trying to build up functions, the relations. Okay. Now something comes with which is not okay with the function it has already built. So the learning rate is going to define how fast it is going to change its mind. Okay, maybe with just one sample which is differ from the already existing function it built, it will change its brain, it will change its function. Okay, or maybe after like 3 4 such samples come, it will change its logic. Okay, so that's the learning rate. Next is the number of epoch. So this is, you can relate is like study rounds. Okay, so basically your model is not going to see the training data only once. Okay, it will iterate over the data again and again, and how many times it will iterate over the data, that you can set up using the number of epochs. So you are going to provide with a lot of data. Okay, and maybe in one go it's going through your data and try to build a function, the relations, the logic. Okay, and it goes through the entire data and it's ready with the logic. Now if it starts again from the start of the data and goes through it over again, maybe it has to update it. Okay. Uh, so that iteration can happen, and that is the number of epochs, like number of times the model is going through the entire data. Next is the batch size. So your model is not going to look into all of your data in one go. Okay, it is going to look into your data into small chunks. Okay, so your batch size is going to define that size of your chunk. Regularization is basically your adjusting of simple and complex model. You can adjust it. Okay. How exactly, that's not needed for the exam perspective, but just like you have an option to adjust between the simple and complex model. And this is very important to control the bias and variance. So for having a low bias and low variance, you have to adjust it. And then you have to remember that all of these parameters, hyperparameters, have to be set before the training. Okay. So before the training, you set all this up, then you do the training, then you do the validation. If you are not okay with it, you again have to adjust these hyperparameter and again do the training. Okay. It cannot be like in the middle of the training you adjust the hyperparameter. Let's first talk about the model fit. So there are two concepts which are overfitting and underfitting. Overfitting is something like model is performing good on training data, but it fails to perform on validation and test data or real world data. Okay. So it's somehow captured, it somehow got too much involved into the training data. Okay. So in this case, this generally happens when your model is too complex. Okay. That means it is learning the noise within your training data. Okay. So let's see an example. Okay. So let's say we are designing a model to detect animal pictures. Okay. It can say like you provide it with the picture and it will identify the animal. Okay. Now we are training it. So if we have provided it with the pictures of different animals, okay, and now it it uh, it learns the noise from the data. What does that mean is it too much relies on the data. That means let's say we have provided it for, let's say, a dog. We have just provided it with three, four dog images. Okay. And so there can be case like, now, if we provide it with another dog image, it will not be able to identify it as a dog. Maybe because it have just seen three, four dog, and dogs have uh, different breeds, right? So that can be one case. Like, so that is the case when we did not send enough of the samples to it. We need more data to train it. Okay, that's one case. Another case is your model is too complex and it learns the noise means it let's say for a tiger. Okay, so for tiger we don't have multiple breeds. Okay, but what your model did was it exactly tried to see the shape, that if that shape exactly matches, then only I will say it's a tiger. Okay, so if you provide a different photo of a tiger, maybe in a different pose, okay, so it will not identify. Okay, so that means your model is too complex to learn the data. Okay, so in this case, the solution is we have to make the model simpler. Simpler and complex is like in terms of feature, how much feature the model is having. Okay, so we make the model simpler so that it can be more generalizing the data. Okay, and then if the training data is less, then obviously we have to train it with more data. Next is underfitting. So underfitting is like model is not able to perform well on the validation test data as well as the training data. Okay. So it does not even perform good on the training data. Okay. So why this happens is the model is not able to capture details within your training data. Okay, it fails to learn the patterns within your training data. Okay, so this happens when your model is too simple. Okay, it's not able to find a proper relation between your data. So in this case, the solution would be making the model more complex. And again, adding more training data can help in this case as well. Okay, just adding training data might not help. You have to make the model more complex so that it's able to make the relations between your data and expected output. Okay, so that's about the model fit. Now, a very important concept is there, which is the variance and bias, and it is related to your model fit. So, variance is basically the difference of your model predictions if the training data is changed. Okay. So, obviously, if your model is overfit, then you'll have a high variance because your model is relying too much on the training data, right? So, in case of overfit, the variance would be high. And then there is bias. So bias is difference between your model's prediction and the actual values, the actual expected values. So we have seen in case of underfit, the model is not able to answer or make good predictions. So if you have underfit, that means you have a high bias. Okay. So the ideal solution is you have a low bias and low variance. And how do we make it happen? So we have seen high variance means overfit, and overfit means model is too complex. So we have them make the model simpler. Okay. And then high bias means the model is underfit. That means your model is too simple. So we have to make it more complex. So basically, what we have to do is we have to balance the model between simple and complex. Based on the training data we have to balance that. Okay. That how much complex our model should be so that it does a proper learning. Okay. So remember, we our goal is always low bias and low variance. There would be some questions attached in the YouTube description related to the topic. Please try them out.